Hello everyone, welcome to my presentation or the research project presentation, which is named Emotional Driven Self-Evolving Agent for MOOC Platforms. This is an intelligent solution for scalable student support. It means that based on the MOOC platform dataset, we build a MOOC classifier and agent and a self-evolving agent in order to get the best response for the query. Introduction and problem statement. MOOC scalability challenges. Massive open online courses, MOOCs, have revolutionized education by providing unprecedented access to high-quality content for millions globally. However, this vast scale introduced significant pedagogical challenges, particularly in managing discussion forum, where an overwhelming volume of student query often leads to inadequate support. There is a survey that MOOC completion rate typically around less than 20%. There are several problems. Student frustration and disengagement. Many student queries, especially the urgent ones, remain unanswered, leading to frustration and a decline in engagement. There is a high dropout rate. Inadequate support frustration is primarily factor contribute to consistently low MOOC completion rate. And there is an ineffective manual moderation. Traditional human-mediated support mechanisms are insufficient given the thousands of posts generated daily. And so, in order to solve the problem, we have our proposed solution, a revolutionary approach. We use the intelligent, self-involving agent system. This is a paradigm shift from reactive, human-dependent support model to proactive, AI-driven assistant that operates continuously at scale while manually maintaining quality and personalization. It has dual approach framework. The first one is template-based agent. This is analogous to a general practitioner or GP in medical term. This GP can efficiently addressing frequently occurring student query using validated response template. It can address the common recurring query in another word. But for the LLM-based agent, function as a medical specialist, they can generate nuanced, context-aware response for complex issue querying during deep domain knowledge. It can handle complex, non-routine query in another word. There are some key benefits. Firstly, it can continuously operate. There are 24 hours, 7-day support without dependency on human moderations. It has target response. Write agents for each query type ensure optimal support quality. It can also enhance learning. It can address urgent needs properly and give the completion rate better result. For the dual agent architecture, our proposed agents employs a novel dual agent architecture as seen above, which is designed to handle the diverse range of student query in MOOC forum. It combines structure and generative approach to automated response generation. For the template-based agent, we use the general practitioner, which addresses frequently occurring student queries. It uses a curated set of validated response template. It is efficient for common straightforward queries and formalized as a Markov decision process (MDP). While for the LLM-based agent, it is used like a medical specialist. It can handle complex issues requiring deep domain knowledge. It can generate nuanced, context-aware response. It can use sophisticated reasoning capability, and it can optimize using genetic algorithm, which is GA. So there are some complementary benefits. It can address both common and complex query with appropriate specialist resource. It can balance between efficiency and sophistication in response generation. For the dual evolution mechanism, first, let us introduce a template-based agent. It uses Markov decision process framework. The template-based agent evolution is formalized as a Markov decision process (MDP), which enabling the application of reinforcement learning (RL) algorithms such as Q-learning. There are some key components, which is state, current template selection strategy, action, template application to student query, reward. This is the most important. This has multi-component function capturing relevance, helpfulness, clarity, and engagement. It also has transition, which is state refinement through experience. We have augmentation technique to generate data, which is called generative adversarial imitation learning. There are some benefits. Using this method, we can have precise template matching, and we have rapid response. We can have continuous improvement and high quality response. And for the LLM-based agent, the other part of the working mechanism, it uses genetic algorithm approach. The LLM-based agent optimization like parameter configuration using a genetic algorithm, GA. This is a meta-heuristic approach particularly effective for navigating the complex, high-dimensional parameter space of modern language model, where gradient-based method may be computationally prohibitive. It has used population-based search. Each individual represents a parameter configuration, exploring multiple solutions simultaneously. It has multi-component fitness. They can fit or measure the fitness of the determined by the quality of the response across standard text queries, evaluated by a comprehensive multi-component quality score. As we can see, it has selection, crossover, mutation, and final evaluation. As for our research contribution, this research bridges critical gaps in educational technology and artificial intelligence through novel framework and methodology for self-involving mechanism and for self-involving educational support agent. It has integration gap. It has filled in the integration app. Novel dual approach framework integrating template-based and LLM-based response generating within a unified evolving system. It has evolution gap and it has filled in the evolution gap. It has rigorous theoretical foundation for both RL-based template evolution and genetic algorithm-based LLM optimization in educational context. It also fills in the evaluation gap. It has comprehensive five-phase methodology for designing, implementing, and evaluating self-involving educational support agent. As for the impact, this research lays the great groundwork for AI systems that perpetually learn and refine their capability and serve human needs of the learning domain. In other words, we use evolving mechanism, and evolve is the key word at here. As for the experiment result, the first part is urgency classification. We can see the performance from standard MOOC post dataset. It has accuracy around 84%, and it also has F1 score around 84%. And for the significance or interpreter of the result, it has a high accuracy, 84% accuracy in identifying urgency student query, ensuring efficient prioritization of support query requests. It also has balanced performance. F1 score of 0.84 indicates balanced, precise precision and recall, effective flagging urgency posts without excessive false positive. It has real-time prioritization too. And for the agent performance, for the template-based agent, evolving through reinforcement learning, Q-learning, and generative adversarial imitation learning, GALE, showed a dramatic improvement, particularly for high urgency posts. We can see from the left graph. And for the LLM-based agent, we can see optimized we're using genetic algorithm to navigate the complex paradigm space of language models, which demonstrates systematic enhancement across all quality dimensions. We can see from the right graph. So there are some key findings. The template-based agent performance achieved 99% improvement in the response quality, and after 11 evolution cycles, the LLM-based agent performed demonstrated 16% improvement in response quality across all quality dimensions. And for the quality achievement, both agents typically reach a perfect score around 1.0, validating the effectiveness of their response evolution approach. And for the urgency classification, as we have said before, the enhanced urgency classifier achieved 84% accuracy in identifying urgent student query within educational forum. The right graph shows this information. So for the implication and future vision, the practical implication is that it reduces instructors' workload. Agents significantly reduce the administrative time, showing educators to focus on complex pedagogical tasks. It also enhances student experience, system to mitigate frustration, boost engagement, and contribute to higher course completion rate. For the future vision, we have present MOOC support, and near term we have evolving agent, and then after that we will have educational ecosystem. In the long term, we will have cross-domain system. This is basically the work of our MOOC data evolving system. So we want to build an evolving system that can learn and build better response for student need. Thank you for your understanding and reading. Have a good one.